right, let's move on to what we call the change of base formula. You know, some of you are going to go to college and you'll never, ever be able to touch a TI-84 again. So get used to that. Make sure you know how to do it with the calculator and without. So we are moving on to lesson 3.3 and we're doing properties of logarithms. Properties of logarithms. Our essential question, can you write logs with different bases? We're going to learn how to use, can you use the property of logarithms? So the change of base formula, a, b, and x are positive real numbers where a cannot equal 1, b cannot equal 1, where log base a of x can be converted to these things. So let's look at the first one. If I have base b, notice it says log base a of x. Notice the x stays on top and the a stays on bottom, but we're writing them with a common base of b. So we're going to write them with a common base of b. This is really handy when all you have is a calculator with a log. You could write this as log base 10. So that you could actually have these b's be 10. But I kind of tell my students, notice the top is on top. Notice the little guy stays on the bottom, because we're going to have to rewrite a few of these. This one does give it to you in log base 10. Notice no matter which base you use, the same thing. The big guy stays on top. The little guy stays on bottom, and we're going to use log base 10. So if I could use any base, what do you think the next one is going to be? It is going to be natural logarithms. And personally, I think this is the easiest one because all you have to do is hit that ln. So notice the x stays on top, the a little guy stays on bottom. So I kind of make it into, in my eyes, like a fraction. So it says use the change of base formula to evaluate the one thing we call it is common logs. Common logs are the ones that we see without natural logarithms. So notice the first one says log base 3 of 16. Well, I'm going to rewrite this as log, and I could use any base. So I'm just going to use log base 10 of 16 over log base 10 of 3. And when I calculate this and put it in my calculator, I get 2.5237. In my book, it tells me to round 4 decimal places. The next one says log base 5 of 22. So I'm going to again use my natural log, or sorry, my log base 10. So I'm going to use log 22 over log 5. So I can just use my calculator, log 22 divided by log 5, and I get 1.9206. So my question for you is, we did it with common logs. What happens when I use natural logarithms? Do you think anything's gonna change if I use natural logarithms? So these questions are actually the same. Trying to put everything in the screen here. So on the top, instead of log base 10, I'm going to use the natural logarithm of 16 over the ln of 3. And what do you find? When you put it in your calculator, you get the exact same thing. So for the next one, I'm going to write it as ln of 22 over the natural logarithm of 5. And I get 1.9206. The properties are very, very important. So we're going to talk about the properties. The first one that we're going to talk about is the product property. And the product property, remember that logarithms are just exponents. So what do I do when I multiply my exponents? Don't I add? So notice that this becomes 2 separate logs. So if I have log base a of u times v, it's equal to log base a of u plus log base a of v. The next property is the quotient property. Again, logs are just exponents. What do I do when I divide by exponents? I subtract. Log base a of u over v is equal to log base a of u minus log base a of v. So notice again, it's the same thing as what you would do with exponents with the exponential properties, but we are working with logarithms because we know that logarithms are just exponents. Power. When I have a power, don't I multiply? So I always tell my students, this guy, he is going to fly to the front. So this is saying log base a of u to the n. And this is the same thing as n times log base a of u. Now, when I work with all those properties in natural logarithms, notice they don't change. The exact same stuff is going to happen. So when I multiply the product property, I add. When I divide, I am subtracting. And when I have a power, that guy's going to fly to the front, and we get n times the ln of u. I'm going to move on to show you how to use these properties. So the first thing we're going to do is expand. The question tells us to expand the property. So notice on this one, I have 3 times x squared times y, and it's just a log base 10, so I don't really have to write log base 10. So I know when I multiply, I add. And notice that I have to write the log every time. So if it was a log base 3, I would have to write that every time. Now, the only thing that I need to take notice of is that 2 in the front. That 2 in the front needs to fly to the front. So my final answer is log 3 plus 2 times log of x plus log of y. And I'm also going to show you how to condense. We're going to do more of these tomorrow, but I'm going to show you how to condense. So the next question is telling us, hey, we're going to give it to you very long, the way that the top answer was. So now they're giving us the answer, and we have to put it back. So some things that we have to remember is, what is this 1/3? Remember, if I bring this 1/3 up here, this is a third of x. Well, what does that mean? If I bring this 5 up here, well, that one's a little bit easier. So we have to know what that third means. So remember, when I go backwards, I'm going to write the log in front. And all of this is going to go inside, and I know that a plus means we're multiplying. Now, I know a third of x is the cubed root of x. And I know I'm multiplying that with x minus 3 to the 5th power. So when I condense this one, notice it becomes log times the cubed root of x times x minus 3, all of that to the 5th power. Let's try another one, as I think these are a little bit more difficult. This 4, we're going to bring it to the top. Minus, what does that mean? That means to divide. So I'm going to have a ln in the front, and on the top I'm going to have x minus 4 to the 4th power, and on the bottom I'm going to have x squared. Great job.